Hey y'all, it's me, Miss B. And today we're talking about triangles. These directions are like completely wrong, so you can just cross those out. That is definitely not what we're doing. Okay, so we're talking about triangles and how to solve for missing sides and missing angles. So first, let's define what a triangle is. So we've got oblique triangles and we've got non-oblique triangles. Okay, so oblique triangles are non-right triangles, and non-oblique are right triangles. And then this little sign right here, oh geez, that's big. This means angle, by the way. So an included angle is the angle that is between two given sides. All right, so there are three things that we need to solve an oblique triangle, and these are the different combinations. So we need two angles in a side, so that's 1, 2, and 3, and that's going to be the law. We're going to use a law of sines with that. So here I have, and this is the order in which you get them to. So we've got two angles and a side. That is, actually that's not super clear. Let me draw something else. So two angles and a side, we use the law of sines, as well as angle, side, angle, we use the law of sines. Okay, sometimes we have two sides and a non-included angle. So here I'm just gonna put two sides. This would be the included angle, so it's not that one. It's going to be this one over here, where it's not sandwiched between two of the sides. So that's a non-included angle. Okay, we have to be careful about that one because there's this thing called the ambiguous case, which we will talk about in a minute. We can have three sides, so that's all three sides. And this is the given information. Or we can have two sides and the included angle, side, angle, side. Okay, so these two use law of cosines, and these three use the law of sines. Those three. Okay, so let's go ahead and talk about the law of sines. So the law of sines is as follows. So we take sine of an angle and put it over that same side. So this is the angle. So we take sine of that angle and put it over A. And because it's a ratio, it's the same thing for all of these as well. So we set those equal to each other, and then we can solve. Or, and of course, we only need two of them to make it true, but the whole thing is true. And so like one of these would be unknown. All right, then we can also do angle over sine of A, and we can write it this way because it's just a ratio, so it doesn't matter if we flip it one way or the other. I usually write it this way. This is the way that I tend to write my law of sines out. But again, doesn't really matter, okay? But when you use the law of sines to find an angle, it's only ever going to give you an acute angle back. So if you have something that looks like this, and you're using the law of sines to find that, geez, that is a terrible triangle. But if you have a triangle, and this is clearly an obtuse angle, if you were looking for that angle, though, it would only give you an acute angle back. So that's what's called the ambiguous case, and that happens when we have side-side angle. That's easy to remember because it spells a bad word backwards. So it makes a funny answer. Okay, so I'll show you an example of how to solve a triangle using that law of sines. We're actually going to ignore this one. I'm not even positive that you have it in your notes because I think I had the foresight to get rid of it. So, erasing it. Okay, so we want to solve this using the law of sines. So here's A. Also, our angles are always across from our sides for naming. So B is always across from B, C is always across from C. So that's A, B, and C. So, in other words, the angle and the side it's across from are always creating a ratio. So we're going to have sine of A over 15 equals sine of 35 over C equals what am I doing? Oh, sine of 50 over B. Okay, so as of right now, given this, we can't solve anything, but if you remember the three sides of a triangle, so angle A plus angle B plus angle C is equal to 180. So we can plug that in. So A we don't know, B is 50, and C is 35. So when we solve that out, 180 minus 35 minus 50, we get angle A is equal to 95 degrees. So we're able to now take this and replace it with that 95 that we just found. So we're finding sine of 95 degrees. This corresponds with this right here. All right, I'm gonna erase this stuff from our triangle just so it's not a mess. All right, so I can use the law of sines 2 times to find that angle. So this one I have all filled out, so it's gonna be my base. So I'm going to write out, I'm gonna change my pen color here. So I'm gonna have sine of 95 degrees over 15 equals sine of 35 degrees over C. Then also, I'm going to have sine of 95 degrees over 15 equals sine of 50 over B. All right, so this is where we want to cross multiply and solve. So I have C sine of 95 equals 15 sine of 35. Divide both sides by sine of 95. We want to keep it exact, so this is what we'll type into our calculator. So C is equal to, so sine 35, sine 95. When I have to, oh, come on. When I type that in, I have to be really careful, so, put parentheses, so I have, 15 sine of 95. I can't remember. 35 first. 35 divided by sine of 95. I type that into my calculator, hit enter, and that is my answer right there. Negative, oh wait, did I do something wrong? Oh, yep, I did. I forgot to put my answer into degrees. So I'm gonna take, oh, dang it. How do I go up? Here we go, hit enter again, and I get 8.6 or round to the nearest tenth. So 8.6 is my answer for that one. So C equals 8.6, and we'll label it units. Okay. Similar way, we'll do this one. Cross multiply. It's not going to show that because of the fact that I'll just draw arrows. So here, so I have b sine of 95 equals 15 sine of 50. Divide by sine of 95. These cancel, and so b equals, when we do that in our calculator, make sure it's in degrees, we get 11.5 units. Okay. So that is how we solve. And so we solved the entire thing because we were given 2 angles and a side. We found 2 sides and 1 angle. So we ended up with 6 in the end. Okay, and then here's another example for us. So it says, you're told that C equals 33 degrees, B equals 10 inches, and C equals 6 inches. This is one where we want to draw a picture ourselves. So we're going to we'll just draw a triangle, call it A, B, and C. And remember, C is always across from its angle. So this is 33 degrees. C is across from C, so this is 6 from here. B is 10, it's across from the 10. And so we are trying to find A, B, and side A. Okay, so first let's find the measure of angle B. I have C and C, so that's a great starting place for the law of sines. So I'm going to say sine of 33 degrees over 6 equals sine of B over 10. Multiply both sides by 10, I get sine B equals, oh wait, no. I'm just gonna multiply both sides by 10 to get sine B by itself. Okay, so then I can plug that into my calculator. However, so I'm gonna get sine B equals some random angle. Okay, instead of doing that, let me rewrite. If I take the inverse sine of both sides, this side I'm left with B, and this side I'm left with my answer. So I'm going to type this in exact. So I'm going to type that in exact. So I'm not going to remember. So we've got sine, oh wait, inverse sine. So shift sine gives me inverse sine of 10 sine of 33, my calculator is in degrees, divided by 6. And I get 65.19. We'll just round it up to 65. So we get 65.19, which we're going to call 65 degrees. So that is what angle B is equal to. Okay, so because we did that, we can easily find what angle A is. Okay, so then we just do 180 minus 65 minus my 33. That's angle A is equal to. And so I get 180 minus 65 minus 33. 180 minus 65 minus 33 gives me 82 degrees for that angle. So that right there is angle A. And we would find that we're not going to, but if we were to, oh wait, no, we found, we're missing something. A, B. Oh, if we were to find side A, we would use law of sines again, just like in the problem before it. Okay, then finally we are going to draw this picture as well. So it says 2 fire lookout stations are 20 miles apart, with station B directly east of station A. So here is A, oh wait, station, east is never east. So station B, this is A, this is B, because this is east. And it's 20 miles. Then they both spot a fire on the mountain to the north. So here is a mountain. And from station A to the fire is 50 degrees to the north, east of north. And then from, west of north is 36 degrees from station B. So there's my triangle. I'm going to clean it up a little bit just for fun. So I've got, this is 50 degrees, this is 36 degrees, and this is 20. And it's asking how far to the nearest 10th of a mile is the fire from station A. So here's my fire on the mountain fire. Okay, so I'm looking for this side right here. This is also side B, so I'm going to go ahead and label it as such. So I want 2 sides that are opposite each other. I have this side, and it's the only side I have, so I need to find the angle that's from the fire. So I'm going to do 180 minus 50 minus 36. Not that. Oh, goodness. 180 minus 50. $76. Did I do that wrong? Why is that negative? Dang it. 180 minus 50 minus 36 gives me 94 degrees. So this is 94 degrees. So then I'm able to do sine of 94 over 20 equals my B, so sine of 36 over B. Let's do some cross multiplication. So I have sine, B sine of, oh goodness, B sine of 94 is equal to 20 sine of 36. Divide by 90, sine of 94, and B equals 20 sine of 36 divided by sine of 94. And we'll type that into our calculator to get an exact value, which is then B equals 11.8 miles. We do want to make sure we label our answers. All right, that's all.